Hey guys, we're going to look at our second day of chain rule, and then we're going to look at derivatives of absolute value. So this first one right here, we actually have three things that are happening. Another way to write this right here would be sine of 4t all to the power of 3. So that third power right there is really around all of whatever sine is. So our outside, very, very outside one would be something to the third power. And since they're using t, I'm going to do that. And then the second layer is sine of t. And then the third layer on the very, very inside is 4t. So we have a double chain rule happening here. The derivative of this one, I'm just going to go ahead and do dy dx, or dy dt technically, is going to be 3t squared. This one, the derivative of that is cosine, and I'll just put t, and then the derivative of this is 4. So if it helps you write out all of them, you can do that. But let's start with the very, very outside. So that would be 3 times something to the power of 2. Well, what's inside of that one is the sine of 4t. So all of that is coming here. Times the derivative of the second layer. Well, that's cosine of something. Well, what's inside of that is the 4t. Times the very inside derivative, which is 4. So we have 3 layers that we had to do chain rule with there. So now I can do 3 times 4, and that gets me 12. I can rewrite this sine as sine squared of 4t. You can write it like that, or you could leave it this way. It doesn't really matter. And then cosine of 4t. There's not really much else that I can do there. On this next one, we've got a couple of layers happening here, but then we also have a chain rule inside. So that very outside thing is x to the 4th. The thing that's inside of that is sine of 2x plus 4x squared. Well, this is a sum of 2, so we can take them each separately, but this one right here is where you have to be careful. We have 2 layers going on here, sine x and 2x. So we've got a chain rule on the outside, and then a chain rule on the inside of part of this piece right here. So let me show you how this works. So if I'm going to do the derivative of this, the outside derivative, that would be 4 times something to the power of 3. Well, the something that was inside of that, well, is sine of 2x plus 4x squared. Now we have to do the derivative of the inside, and this is where we have to be careful. So times the derivative of sine is cosine, 2x is on the inside, times the derivative of that inside is 2. Then we have plus the derivative of 4x squared is 8x. So this all is multiplied by this piece right here. So I can make things look maybe just a teeny bit nicer, but not by much. So the derivative is equal to 4. Then we have sine 2x plus 4x squared, all raised to the power of 3. And then I have all of that times 2 cosine of 2x plus the 8x right here. Now, we could distribute that in there, but I don't think that's going to make it look any nicer at all. Number 3, chain rule combined with other derivative rules. So this is a product rule. We did one kind of like this together. So we have a chain rule here with a chain rule here, but inside of this, that's a product of those two. So we have a product rule with this one and that one, but we also have chain rules inside of each of those. So derivative. Let's just start with this first one. Derivative of this first one. Well, the outside of this is x squared. The inside of this is 2x minus 1. So if I take the derivative of the outside, that would be 2 to the power of 1. The inside just stays as is. Times the derivative of the inside, well, that's just 2. Leave the second one alone. This is product rule. So this is our first function. We just took the derivative of that with chain rule. Leave the second part alone. So cosecant 2x. Plus, that's the product rule part, leave the first one alone, 2x minus 1 squared. Now we're going to take the derivative of this cosecant 2x. So your outside on this is the cosecant x. The inside of this is the 2x. So chain rule with this one. The derivative of cosecant, well, that is, I'm going to go ahead and put parentheses, negative cosecant something times cotangent something. So the something that's in the inside of it is the 2x. So negative cosecant cotangent is the derivative of the outside. Now times the derivative of the inside, well, that's just times 2, and I ran out of room. Now the only thing we have to do is kind of make this look a little bit nicer. I'm going to look on this side of my plus sign first. So I have a 2 times 2. I could go ahead and make that 4. I'm going to leave this as 2x minus 1 and cosecant 2x right here. You could distribute that 4 if you wanted. Now on this side of my plus sign, I've got 2. I've got a negative. So I'm going to go ahead and change this to negative 2. I'm going to leave this 2x minus 1 squared, and then that just leaves me with the cosecant 2x and the cotangent 2x. And that's about as pretty as I'm going to make that one right there. So this had a product rule because we had this function and this function, but each of those had their own chain rules there. So if you need to pause, rewind, try it again, you can. So the trick for finding the derivative of absolute value is to realize that absolute value is simply just whatever that inside is, it's the square root of that squared. Chain rule takes over after you substitute. So let me show you what I mean. So we know that when we take the square root of something, it is that plus and the minus. That's where it's going to get you the positive and the negative for your square root. So what I can really do is realize that this absolute value derivative, we could really just change it to be the derivative of square root of x squared minus 4 squared. These mean the same thing, and the square root, what's happening is it will make you get that positive and negative that the absolute value requires. Okay, so I'm going to rewrite this as this is the same thing as the derivative of x squared minus 4 to the second power raised to the half power, because half power is the same thing as square root. Now, what I do not want you to do is do power to a power here, because that will make my trick of absolute value not work. It's going to go back to just this right here, and the absolute value is just going to be forgotten. So in order for this trick to work, we have to do this multiple step chain rule here. So the very outside is something to the power of half. Then inside of that is something to the power of 2. And then inside of that is the x squared minus 4. So we have 3 different layers that we are dealing with. So this one, when I take the derivative, I've got 1/2 x to the power of negative 1/2. When I take the derivative of this one, I've got 2x. And then when I have the derivative of this, I have the derivative of 2x as well. So those are our 3 layers, but remember, something has to go inside of each of these. So derivative, the very first outside layer, it is 1/2 times something to the power of -1/2. Well, the thing that's inside of the very outside thing is x squared minus 4 all squared. Times, go one more layer down. Now we're at x squared. So that's 2 times something. Well, the thing that's in x squared is x squared minus 4 times the very last derivative of 2x. So I've done my 3-layer chain rule, and now we want to make this look a little bit nicer. Well, 1/2 times 2 times 2x, that gets me 2x. But I also have the x squared minus 4. And then on the bottom, what I have is this piece right here. All of this needs to go to the bottom. So what I have is the square root on the bottom, that's that -1/2, of x squared minus 4 squared. And then from here, we have to recognize, remember the trick of squared and square root is the same thing as absolute value. So your final answer in absolute value form would be 2x times x squared minus 4 on top over the absolute value of x squared minus 4. Okay, so derivative of absolute value functions. So another way I can write this is u over the absolute value of u times du. My u would be x squared minus 4. So the rule is u over absolute value of u times du. X squared minus 4 over absolute value of x squared minus 4 times the derivative of u, well, that's 2x, and then that's nothing. So this is what I get right here. If I make it look a little bit nicer as one fraction, I would have 2x times x squared minus 4 on top, absolute value of x squared minus 4 on bottom. And if I compare that with what we did after the chain rule, you get the same thing. So if you can remember your rule of u over absolute value of u times du, this is going to save us time. We just did this right here to build the idea of what the actual rule is. You do not ever need to go through here unless you just absolutely forget, and then you would have to remember the half and square root trick, or the squared and square root trick. Okay, so what does that mean? If we take this one right here and use our rules for absolute value, the thing that I'm taking the absolute value of is my u. So u, which is x to the third plus 3x, over absolute value of u, which is x to the third plus 3x, times the derivative of that thing that I just called u. So du just stands for the derivative of u. Well, what's the derivative of 3x? It is, or x to the third, sorry. It is 3x squared. What's the derivative of 3x? That's just 3. So my derivative of that function g is this right here. When x equals 2. So now I take that derivative at 2. So everywhere I see x, I'm going to put 2 in there. So 2 to the third power plus 3 times 2 over absolute value of 2 to the third plus 3 times 2 times 3 times 2 squared plus 3. 3 squared, or no, 2 to the third power plus 3 times 2, that's 14. Absolute value of 14, simply just 14. times 3 times 2 squared plus 3. 2 squared is 4 times 3, that's 12, plus 3 more, that's 15. So this is 1 times 15, which equals 15. Write the equation of the tangent line. So all this that I just did, that was the slope. That just got me slope. M, my slope. I want to find my x and my y. Well, I have my x. My y value is simply just where I do g of 2. So this is absolute value of 2 to the third plus 3 times 2. Well, we already know that from the bottom down there, that's 14. So that's my y value. X is 2, y is 14. So the equation of the tangent line is y minus 14 equals m, my slope, 15 times x minus 2, that x value right there. Now, I want you to look back at number 2 and see if this derivative rule that I just showed you, u over absolute value of u times du, works. So I'm going to look at this right here. My u would be x squared minus 4. So the rule is u over absolute value of u times du. X squared minus 4 over absolute value of x squared minus 4 times the derivative of u. Well, that's 2x, and then that's nothing. So this is what I get right here. If I make it look a little bit nicer as one fraction, I would have 2x times x squared minus 4 on top, absolute value of x squared minus 4 on bottom. And if I compare that with what we did after the chain rule, you get the same thing. So if you can remember your rule of u over absolute value of u times du, this is going to save us time. We just did this right here to build the idea of what the actual rule is. You do not ever need to go through here unless you just absolutely forget, and then you would have to remember the half and square root trick, or the squared and square root trick.